Alright, we're going to do our second graphing lesson today, and this lesson is on distance. So today we're going to be able to determine the distance between 2 points. Alright, so here's your do now. So this is questions number 9 and 10. When you are done with these two questions and you've reviewed the answers with me on the video, you can rip this page out of your notebook, make sure your name is on it, and then turn it into the box because you will get a classwork grade for it. So go ahead and pause the video now and try these two problems. Alright, so question number 9 says, what point lies midway between 7, 3 and -1, 4? So we know two different ways to do that. I'm going to show the algebraic way first, and then I'll show the graphic way. So, the algebraic way, I'm going to line up the 2 points. I've got 7, 3, and I've got -1, 4. And I know that the midpoint, or the point that lies midway between them, is the average of these 2 points. So I'm going to add the 2 points together and then divide by 2. So 7 plus -1 is 6, and 3 plus 4 is 7. And then I can divide these by 2. 6 divided by 2 is 3, and 7 divided by 2 is 3.5. So that's one way we could have done that to get this answer. There is another way. Oops, that's not what I want. Alright, so let me erase these ink things. So we got 3, -3.5. Boy, this is more difficult than I thought. Alright, we're almost there. We're going to show how to do this graphically too. Alright, so I've got the point 7, 3. So over 7, up 1, 2, 3. So this point right here, and then the point -1, 4. -1, up 1, 2, 3, 4. So in order to find the point that's midway between them, first let's figure out how far down I have to go. So I have to go down 1. So that means I'll be going down 1/2 to go midway between. So it'd be somewhere on this line. And then how far over do I have to go? I have to go over 1, 2, 3, 4, 5, 6, 7, 8. And half of that is 4. So 1, 2, 3, 4. So this is the midpoint right here. Right? So that's the point over 3, up 1, 2, 3 and a half. So we got the same answer either way. 3.5 is what you should have gotten for question number 1. Or question number 9, rather. Alright, so question number 10, it says, name an angle that's supplementary to BGA. Alright, well, first of all, let's find angle BGA. BGA is this angle right here. And we're looking for something that's supplementary to that. Well, what does supplementary mean? It means that they're going to make a straight line together. So we could either be looking at, let me switch colors really quick. We could either be looking at this straight line right here that BG lies on. And so if we're looking at that line, we have this angle, and then we'd have the angle AGE. So 1 is angle AGE. There's one other one that we could be looking at here too. Alright, so we still have the angle BGA, but now instead we're going to look at this line that AG is on, this line right here. And so if we've got this angle here, the angle that would make it supplementary, or that would make that straight line, would be BGD. So we could also have angle BGD. And this is one of the hardest things to see from that very first lesson, or from the angles lesson, is trying to figure out which angles are complementary or supplementary in a picture. Alright, let's go ahead and move into the notes for today. Don't forget to put your name on this paper and tear it out of your notebook and turn it into the box. Alright. So we haven't had an anticipatory set yet, but I wanted to have one today because I wanted to remind you of something that you learned in pre-algebra. So if you're given this right triangle here, now it's important that it's a right triangle. Do you remember any way that you could solve for this right here? This is something that's on your geometry formula sheet, and it's something that you probably did a lot of in pre-algebra. And I'll give you a hint right here. All right, does this look familiar to anybody? A squared plus b squared equals c squared. This is called the Pythagorean theorem, and it's used to find missing sides of right triangles. These two right here, a squared and b squared, are what's called the legs. They're the two sides of the right triangle that make the right angle. And this side right here, c squared, is the hypotenuse. That's the side that is across from the right angle. So if I wanted to solve for x here, I could take these values and plug them into the Pythagorean theorem, a squared plus b squared equals c squared. So the 10 and the 4, it does not matter which direction I plug them, like which order I plug them in. So I could just take 10 and plug it in for a, and 4 and plug it in for b. So I'd get 10 squared plus 4 squared is equal to, and now this, because it's the hypotenuse, has to be c. So I'm going to put x squared here. Right, and then I'm going to simplify this. Well, 10 squared is 100, and 4 squared is 16, and x squared, we don't know what it is. 100 plus 16 is 116, and that equals x squared. And that's great that now we know what x squared is, but we don't want to know what x squared is. We want to know what just plain old x is. So what is the opposite of squaring something? Well, the opposite of squaring something is square rooting it. So we would take the square root of both sides. So we would get that x is equal to the square root of 116, or you could simplify that. So in your calculator, you'll hit second and then the square root button, enter 116, and you get like 10.77 or 10.8. So x is approximately equal to 10.77. Alright, so we might use this today. I'm going to give you a couple different options for the distance formula, but this is one option that I tend to use a lot. So, let's go ahead and take our notes. So you can go ahead and fill in, you can go ahead and write this into your notes section, and then we'll fill in the blanks together. So you can answer distance questions using a couple different methods. One is the Pythagorean theorem, which we just reviewed. Another is called the distance formula. Now the reason I give you another method besides the distance formula is because the distance formula is hard to memorize and it's not on your formula sheet. So if you want to use it for your tests, you have to memorize it. And I think it's easier to memorize the Pythagorean theorem and know how to use it. And actually, the Pythagorean theorem is on your formula sheet if you forgot it. But the distance formula is not. Alright, so the Pythagorean theorem is a squared plus b squared equals c squared. We learned this in pre-algebra. You may have even done it in 7th grade math. But and it's on your formula sheet. So this one you don't have to memorize. If you want to use the distance formula, you actually have to memorize this. And not only do you have to memorize it, but you have to be able to use it without making math errors, and that's kind of hard. So in our first class example, I'm going to show you how to do it both ways. After I've shown you once with the distance formula, I'm probably only going to use Pythagorean theorem the rest of the time, because I haven't memorized this, and I just think it's easier to use Pythagorean theorem. Alright, so let's go ahead and get into our first example. We're going to find the distance between the point 3, 4 and the point 8, 0, and we're going to round our answer to the nearest tenth. So we've got to be really careful with our rounding. You guys are going to make a lot of rounding mistakes, and it's going to make all the difference in the world on a problem. So no rounding errors. Alright, so like I said, I'm going to use the Pythagorean theorem, but right now I'm going to show you how to use the distance formula. So I'm going to show you once how to use the distance formula. These ordered pairs are an x and a y, so if this is point 1, this is x1 and this is y1, and if this is point 2, This is x2 and y2. And now it doesn't matter if you had decided this was 0.2 and this was 0.1, that'd be fine also, just as long as you're consistent with labeling the x's and the y's. Alright, so now I'm going to plug this stuff into this formula. So I'm going to have d is equal to the square root of, so I've got x2 minus x1. Well, x2 is 8 and x1 is 3. So I have 8 minus 3 squared plus, and then y2 minus y1, that's 0 minus 4. 0 minus 4 squared. Alright, so now I'm going to keep carrying that down and simplifying it. 8 minus 3 is 5, so that's 5 squared. 0 minus 4 is negative 4 squared. Alright, I'm going to keep carrying it down. 5 squared is 25. Negative 4 squared. Now, if you don't enter this into your calculator correctly, your calculator is going to lie to you. What does it mean to square something? It means to multiply it by itself. So this is negative 4 times negative 4. A negative times a negative is always a positive. And then 4 times 4 is 16. So you should get positive 16. Okay? You will not get a negative number. If you type this into your calculator like this, your calculator is going to follow the order of operations. It's going to do the exponent first, and then it's going to deal with this negative sign. So make sure that if you're going to put this in your calculator, you put the negative 4 in parentheses to show that you're squaring the whole thing. Alright, so then we're going to keep simplifying. The square root. 25 plus 16. Well, that's 41. Okay, and it said to round our answer to the nearest tenth. So if I type into my calculator the square root of 41, I get 6.403. So I get d is equal to 6.403. Alright, so to round to the nearest tenth, this is the tenth place. So I've got to look right behind it. Is this 0 big enough to round this 4 up? No, it's not. So this 4 needs to stay the same. So we're going to say that the distance is approximately equal to 6.4. Alright, so that's how to do this with the distance formula. Now I'm going to really quickly, hopefully, show you how to do it with Pythagorean theorem. Alright, so I am going to change ink color. Alright, I'm going to plot these 2 points. So the first point is 3, 4. So over 3, up 1, 2, 3, 4. So this point right here. And then the point 8, 0. Over 8, up 0. Over 1, 2, 3, 4, 5, 6, 7, 8, up 0. So that's this point right here. Alright, I am going to make this into a right triangle by going straight down and straight across. Alright, do you see how now we have a right triangle? Here's our right angle. And so now I can do a squared plus b squared equals c squared. Because I'm trying to solve for this. I'm going to label it c, because you're always going to be solving for the hypotenuse here. I'm trying to solve for this. So I can count. This is 1, 2, 3, 4. So this side is 4. And this side is 1, 2, 3, 4, 5. This side is 5. And so now I can just use the Pythagorean theorem. A squared plus b squared equals c squared. And these two numbers are a and b, so I'm going to plug those in. So I've got 4 squared plus 5 squared equals c squared. And then I've got 16 plus 25 equals c squared. 16 plus 25 is 41. And then I just want to know what plain old c is, so I take the square root of both sides, and I get c is approximately equal to 6.4. So you get the same answer either way. It's just a matter of which way you prefer to do it, and I happen to prefer using the Pythagorean theorem. So on the rest of the examples, there will be 2 more class examples and 3 student examples. I'll be using the Pythagorean theorem every time.